Once again, with these, remember, just like we talked about on Monday, just find the circumference and then figure out what the fraction is, right? So with this first one, you've got 2 pi r. They give you the radius is 11 inches. So you know that the circumference is 22 pi, right? That's what the whole way around is. But we don't want the whole way around. We just want 310 out of 360, right? So let's figure that out. And you know, that may or may not come out real nicely. You do it, probably gonna be over 18, I think, is what it's gonna have to simplify to. So you can just, you can just do it out on the calculator. You're gonna get some kind of ugly number. Yeah, over 18. Because the zeros are gonna cancel, right? There's a factor of 10. And then 31's prime, so we can now effectively ignore this, right? 22 has a factor of 2 that can cancel with the factor of 2 down here. So you end up with over 18. So you end up with like 31 times 11, which is 341, and then 18 on the bottom. Whatever that is, right? Roughly a little bit less than 19 pi, right? Which makes sense. It's almost 22 pi. 310 is almost the whole thing, right? All right, we feeling okay with that one? Any comments, concerns? All right. Let's do this other one. With this second one here, the radius is 12. So again, we're going to just figure out the circumference of the whole thing, which should be 24 pi, right? 2 times the radius, and then with a pi, times pi. So now we don't want the whole thing. We want 87 degrees out of 360 degrees. So that's also probably not going to be like super duper great. Our one saving grace is the fact that this 24 is going to cancel most of the stuff with the 36, so the 360. So I'm just going to go straight for the calculator on this one. 87 over 360 times 24 pi. So let's see what happens. 87 times 360. No. Divided by 360 times 24. Oh, it's not that bad. It comes out to a decimal that's not like super wacky. 5.8 pi as our. You could totally leave it as 5.8 pi if you wanted to. You could be like 29 over 5, right? Both of these representations mean the same thing. Both of them are good. I don't think I saw any problems where they're going to insist on a fraction. But if they insist on a fraction, you're going to want this one. Or if like the decimal comes out really ugly, like some sort of weird repeating decimal. I think I remember one of the answers that someone had earlier ended up being something over 36. And when you try and make a fraction with that, it didn't come out very nicely. It's some ugly random repeating decimal. So just be aware. the ugly random repeating decimals, like we had with the 11 inches radius, you're gonna have to figure that out as a fraction. If you're having trouble with that, let me know. We can sit down and we can go over that sort of stuff. But yeah, if it comes out to it, but if it terminates nicely as a decimal, if it just stops like this one, 5.8, you can leave it as 5.8. The answer blank should accept 5.8 pi as a valid answer. All right. So what are we going to do today? Basically, we're going to do what we just did with the arc length, but now we're going to do it for area. We're going to find a piece of the area. We're going to start by reviewing how to find the area of a circle. Then we're going to move on to talking about what happens when you've got a slice of a circle, like a normal everyday pizza slice, whether it's, you know, the one that you normally expect, not the weird fancy square cut, right? So once we figure that out, that's called a sector. Then we're going to talk about a segment, which is the other type of pizza slice, where it's the fancier, just like cutting randomly into the thing. And so that's what we're talking about today. So let's start off by talking about area, just in general. Identify the radius, you know, make sure that what you're doing is you're using the radius. Sometimes they're going to give you the diameter, and you're going to have to take that, cut it in half to find the radius. So just sort of as you're going through doing these problems, be mindful of what information you have versus the information that you actually need, okay? Because sometimes those two might not be the same thing, and then you'll be confused, like I was earlier when I tried to use a diameter to solve for the area of a circle, and it didn't work. And I was like, why is my answer wrong? Oh, because I'm stupid. Okay, I get it. So just pay attention, you know? Watch the information that you're being given. And I'll write this nice and big because I know it's super teeny tiny for us here in meat space. This is really tiny. Now it's big. I think hopefully there are no questions on this part. Feeling good about it? Yeah? Everybody has what they need written down, the good old pi r squared. There's one of my friends in college always had this joke, like, but that's wrong. Pi r round, cake r squared. I got a giggle, sounds good. All right, let's talk about this now. Here's a picture of a wrestling mat. We want to figure out the area of the circle part of the wrestling mat. Now, one thing to keep in mind is that where they put the number is designed to communicate to you what they're actually talking about. See how it's here in the center of the circle like that? When they do that, they are communicating to you that they are telling you the value of the diameter, right? Because it's in the middle. If the 32 is like over here, then they'd be like, okay, that's a radius. So if it's in the center, presume that it's a diameter. All right? If it's not in the center, then you can be like, oh, it's probably a radius. Okay? Because you know, sometimes they're just going to put it there, and then you're not going to know, well, what does that 32 feet represent, right? So just be aware that if they are communicating properly, if it's in the center, it should be the measurement of the diameter. If it's off to the side, it should be the measurement of the radius, okay? So we're going to do this. We're going to say, okay, well, then what's the radius? Well, if the diameter is 32, the radius had better be 16 feet. And now we can just do our problem. Pi r squared. Well, what is 16 squared? It is 256. And then our units, we were in feet. So now, since we're area, we're feet squared. So give this one a try. Same idea. Now they're just giving you words. Hey, it's a 42-foot diameter. Find the area of that figure. So we got a 42-foot diameter, which means our radius is going to be 21 feet. So now we're just going to go through and do our problem. Once again, pi r squared. Well, what's r? It's 21. This is the one that I screwed up on. As I was taking my notes, I went and I put 42 in, and I squared that, and I was like, but why this number so big? Oh, that's why. So only 21. You don't have to just square the radius, not the diameter. So, and remember, when you're doing this, when you are calculating out your answer, feet squared, you are not gonna include pi in your calculations, right? You're just gonna figure out what the numbers all come out to, and then take pi and set it next to the number, because we don't want to actually have to include that, because then that would make our answer ugly, right? It would. What did you come up with? Like 1400 something? Yeah. Okay. So the thing of it is, unless they tell us, unless they specifically give us a directive to say, I want to know to the nearest square inch, what is the area of this shape? Which, I mean, is a valid thing to ask if you need to plot a garden, right? How many square inches of soil are going to have to be on there, right? And then obviously in that situation, you'd multiply by like an inch or two so you had the correct depth of it. But like, you need to know the dimensions in terms of like cubic feet or square feet or whatever, so you can actually buy the amount that you need. But here, $441 pi, perfectly fine, right? What is a sector? I was talking earlier about like in terms of pizza, because I'm hungry and it's not lunchtime yet. So when we're talking about a sector, think about it like just sort of the normal pizza cut, where we've got all the, like a wedge in the center like that. When we're doing it this way, we can find the area super easy, because it's the exact same situation as what we did in the bell ringer with the arc length, right? It's just taking the area of the whole thing and saying, okay, well, what percentage is the actual part I want, right? So however many degrees out of 360 times the area. And that's what they're saying right here. You know, and again, they're talking about the product of the ratio, blah, blah, blah. You don't have to think about it with fancy terms. What fraction of the area of the circle are we working with, right? What do we want? So find the area of the circle and then multiply it by that fraction. And that's all it is. The angle over 360 times the area of the circle. All right? So let's go ahead and use this, right? So I'm going through here and I'm seeing I've got the radius, and they want us to figure out the area of this little slice, right? So all you have to do, just start with the area. Don't overthink this. Well, R is 15, so let's do that. Right, and then our part that we care about is 72 degrees out of the whole 360. So let's just, and we don't even have to do 72 out of 360 if you know that 72 degrees is a fifth, right? So you could do it this way. Or you could be like, oh wait, 72 degrees, that's a fifth of a circle. Whatever you see first. Don't feel like you have to do a particular way, right? You're going to get the same answer either way. Just depends on what you see first. Remember, the fastest way to do a problem is the one that gets your pencil writing the quickest. So I'm looking at this and I'm saying, all right, well, let's do this one. 225 divided by 5, what is that? 45. One way to, one thing to, I don't know if this makes it easier or harder, I don't know, but especially when I knew this was 15 times 15 already, I just take one of the 15s and divide it by 5, and I've got 3 times 15, and that's 45, right? That's just sort of how my brain went, because it was like, all right, well, it was this up here. Let me break it down so I don't have to think as hard. That or ain't nobody gonna know.
I'm just like 25, that's 5, and then 100, that's 20.
Yeah, that's totally cool too. I like that. That's good. Different people interact with math in their head in different ways, and it's okay for us to find our own path. As long as you get the same answer I do, it's okay. So either way, 45 pi centimeters squared. Can't forget the units. I've been really focused on making sure that I write the units out every time, because on the AP exam, they get mad at you if you don't put the units. So you always got to be careful with that. Your turn. So the circle has a radius of 4 inches. We want to know what the area of the sector is, bounded by a 45-degree minor arc. Leave your answer in terms of pi. So this direction, leave your answer in terms of pi, is the null direction. If you are not told anything about how to leave it, leave your answer in terms of pi, just like we've been doing, number pi. Unless they specifically tell you and they say, hey, this needs to be rounded to blah, blah, blah. Don't do no rounding. Leave it in terms of pi. Once again, take a minute. What's the area of the whole thing? The radius is 4. So the whole area had better be 16 pi, right? That's the whole thing. Now we've got a 45-degree minor arc. Depends on you. You can be like 45 out of 360, or you can be like, well, 45 degrees, that's like an eighth of a circle, right? In fact, exactly an eighth of a circle, which is the point. But either way, regardless of which way you do it, again, you can write it either way. It's basically, do you want to simplify that fraction early, have smaller numbers to multiply and divide with, or do you want bigger numbers to start with and then you have to use bigger numbers if it's the same thing. Either way, you're going to get the answer of 2 pi, right? And what are my units? My units are inches squared. All right. Not that bad, right? Exactly the same as what we did on Monday. The only difference is now it's pi r squared instead of 2 pi r. So let's now carry forth into our last little piece of stuff. Now, I've had many quarrels with the content of this book over the years. There are very few things that I look at this book and say, you know what, I really like this thing that they did. Here's one of the very few. This image is perfect. Because you take the area of the sector, you subtract the area of this triangle that's in here, and what you get is this sliver on the outside, and it's called a segment. And that's what a segment is. Basically, you take the sector, cut off the triangle, you get the little slicey along the side. And literally, that's what we're going to do to calculate it. We're just going to have the area of the sector. We're going to subtract the area of this part of the triangle. Now, there are lots of ways to find the area of a triangle, but since we're already in this vein of using the radius, why would we want to insert more things in there? I don't want to do no base times height, right? I'm going to have to physically calculate a base and physically calculate a height. And ain't nobody got time for that, right? Why not instead just do... And the best part about this is that we only have two things we need to know what they are: the angle, which they're going to tell you, and the radius, which they're going to tell you, right? And after that, literally all of this is just taking the calculator, punching some buttons, and throwing it in there, right? Because with very few exceptions, this is not going to come out very nicely. I've had situations where it'll come out kind of okay, like it'll be something pi minus something, just because the numbers work really well and the angle worked really well. But generally speaking, these are going to be the types of problems where, like, you go through and it's, oh, this is a gigantic, horrible decimal, round to the nearest however much, right? On that note, as I say something good about the book, I'm going to say something bad about the book. Because if you go through, it will, and because I went and I looked, I saw what they did. It will go through and like, oh, now simplify this part, simplify this part, simplify this part, and then put it in the calculator. Why not just put it in the calculator from the jump, right? And that goes for any problem that you do. If they say for their, as part of their directions or in the little blue text at the bottom, round to the nearest whatever, you go, okay, and then type it all in the calculator, hit enter, and get what you get. And then just, right? Don't worry about trying to simplify something that you ain't got to simplify. Just in general, try and keep your workload as a human being to a minimum, because why would you want to do more work when you could do less work? 100% of the time, 100% of the time, when given the option, you should choose the less work option, because that's not where the good stuff is anyway, right? Like doing all that extra work doesn't prove that you're smarter or dumber. It just means that you wrote more, which, that can be a thing. There's something meditative about writing a lot. I mean, if I had a problem with writing, I wouldn't have a fountain pen around my neck right now, right? So, but like with this stuff, if you're torturing your brain to try and make that as simple as possible, and then you're just going to throw it into the calculator anyway, find a better hill to die on, So here we go. And again, it says round your answer to the nearest tenth. Maybe do one or two steps out on paper. Like, okay, well, what is my thing? We've got this is what I've got to figure out. So let's put all the numbers in. What's my radius? 18. what's my angle? 60 degrees. So let's put everything in. That's an 18, right? And to be honest, what's great about doing it this way, with, you know, you've got these two working pieces, is that this formula will work regardless of what it is that you're trying to find in terms of the size of the segment that we're working with. Because even if we're talking, like, let's say the shadings were reversed here, that was the big piece that you're looking for. If you used 300 degrees, everything would still come out properly, even though it was no longer the sector minus the triangle, because it basically is the other one, it's the sector and then plus the triangle in here, right? Everything still works out. And you will talk about this more, not this situation specifically, but just why sine works that way. When you get to pre-calc, you'll talk about the fact that we in geometry, for the purposes of trigonometry that we talked about, sine doesn't make sense above 180 degrees, right? Because how can you have a triangle that has an angle bigger than 180? You can't even have it equal to 180 degrees, never mind bigger, right? So eventually you will talk more about sine, cosine, tangent in terms of something that's going to make it more broadly generalizable. And it'll make more sense why, if you were to put a big number in here, like 300 instead, why this would still work. Basically, when sine is that big, sine actually ends up being negative. There's a really great visual, you'll see it next year, but it all works. So like if you were to do this, just using this equation and running on autopilot, it'll all still come out in the wash. It'll all still work because the sine will flip and then it'll be like adding the triangle instead of subtracting the triangle, and it works great. But anyway, so I'm not gonna like try and do anything with this. I've written that out, now I'm gonna put it in the calculator, right? It's gonna come out to something super ugly because pi is in there and the sine of 60 is radical 3/2, I think. 60 divided by 360 times pi times 18 squared minus 1/2 times 18 squared times the sine of 60. And make sure you're in degree mode. You should get something like this. 29.3498878. And it keeps on going. Is that what y'all got? Yeah. Hopefully. I'm trusting y'all. But that's what. Okay, yeah, that should be good. And then they say round to the nearest tenth. So we look here. That 4 means that we round that down, and so our final answer should be 29.3. And what are my units? Inches squared, yes. All right, so when it comes to this stuff, the segment, the little sliver part, you are not going to be forced to simplify that down, I don't think. They wouldn't do that to you. Or even if it did, all you would do, if they were asking for it, and leave it in terms of pi, then what that means is that this second part's going to come out real nice. You throw the 1/2 18 squared sine of 60 into the calculator. It comes out to be some kind of thing that you can like actually work with. And then do all the other stuff other than the pi. Then you'll get number pi minus number. And then that's what you would end up with. For this one, if they're just saying nearest tenth, just literally take the whole thing and just put it straight in there. Don't skip anything. And just let the calculator do all the work. Let your brain rest easy, knowing that as long as you typed it in right, your calculator is going to give you what you asked for. But one definite sign that you probably put something in wrong somehow is if you get a negative answer, 5 sure your answer is wrong. Okay? Okay. Last one. Again, you're gonna find the area of the segment. I'm gonna try and make this bigger because I know this is tiny. This is 4 meters, and then this is a right angle right here. That didn't help very much. Oh well, I tried. Take 2 minutes, give it a try. Here they give you a radius of 4 meters, and they give you an angle in here in the center that's 90 degrees, this little box thing. So give that a try. Make sure that you can do it. All right, so we go through, we figure out, all right, well, the radius is 4. The angle that we care about here is 90 degrees. So we can just throw that in. 90 out of 360. Pi, well, r is 4, so 4 squared minus 1/2 r squared times the sine of 90 degrees. And actually, this one in particular comes out really, really, really nicely. If you were to know how to do this by hand, which I haven't taught you how to find the sine of 90 degrees by hand, or really any by hand, which we don't need. But next year, when you take pre-calc, you'll learn how to do some special numbers by hand. 90 just happens to be one of them. And when you go through, the sine of 90 actually technically is 1. So this becomes, this actually does simplify down to something pretty cute, 4 pi minus 8. Now, whether you typed it into the calculator like that, or you know how to simplify it, which you get like 4.56 something, right? And then again, they say to the nearest tenth. So this 6 means we round up, so we end up with a final answer 4.6. Is that it? That's meters squared. I totally understand. IN looks like an M from far away, because of course it does. I get that confused like every single day. So especially if you make a really big tail on your M, like I sometimes do, and you smush them together because the kerning isn't as good as it should be, because that's my handwriting for you. All the time. I will actually be in the middle of writing something. Wait, was that meters or inches? My handwriting doesn't. On the best of days, it's terrible.